Hi everyone, welcome to the third and the final video of this playlist of designing a chat application. In this video, we will be diving deep into the designing of our chat application. Mostly we will be discussing three main topics, that is the service discovery, the messaging flows and the online and offline indicators. So without wasting any time, let's deep dive into each of these components. First we have this service discovery. So what is service discovery? So the main function of this is to recommend the best chat server for a client depending on the geographical location, on the server load, etc. So recommend best chat server for the client depending on, say, geographical location and the server capacity, etc. So a famous service discovery is like the Apache Zookeeper. This can be used as a service discovery service to recommend the best chat server to the user. And how it works is like it registers how it works, it registers all the chat servers, and once a user tries to connect with a particular server, so it connects with the best server to the client using some predefined criteria. Connects client using predefined criteria. So if we see this in a flow diagram, so suppose user A tries to connect with the chat server. First it logs in, the load balancer distributes the request to a particular app server which handles the login service, and once the user is authenticated, it goes to the Zookeeper service. It is the service discovery. It checks from the servers, let's say server 1, server 2, let's say server n, there are n servers, and server 2 is the best applicable server for this particular client. And once this server 2 is allocated for this user, so user connects using the WebSocket protocol. If you remember, we discussed this in the previous video in our high level design. It connects with the server to chat server. App server authenticates the user. So this is a high level flow diagram of how user connects with a particular server. So it logs in, authenticated, Zookeeper, and then finally this. So this is service discovery. Next we will be looking into message flows, how 1:1 chat application happens, or chat happens, or group chat happens, etc. So the second thing we will be looking into is the message flows. First we will be looking into 1:1 chat flow, and we will understand this with the help of a flow diagram, so it is very easy. So suppose this is our user A, or this is the sender, which connects with the chat server. Let's say this is chat server 1 and sends the message to the chat server. Chat server in turn connects with the ID generator for the message ID. If you remember our data model, ID generator, it gets a message ID, and along with the message ID and the message, it pushes the message to a message sync queue for the receiver, and along with that it is also stored in the key value store. The message is stored in the key value store. So now, depending on the receiver's action, so if the receiver is offline, the message queue pushes the message to a notification, third party notification service. So this is our notification service which notifies the offline user about a new message, incoming message. And if the user comes online, so that user or the receiver, let's say it connects with another chat server, so the message is sent. So this is online situation and this is offline situation. So when it comes online, so the message is sent to the chat server to which the receiver connects, and finally the message is sent to the receiver. So this is the flow diagram first the user logs in and the application and connects with the chat server. Chat server communicates with the ID generator, gets the message ID along with the message, pushes it into the message sync queue of that receiver. Also it pushes into the database server, key value store. It also, if the user is offline, the message is sent to the notification service, and if it is online, the message is finally sent to the user. So this is for 1:1 chat application. Another thing which question might arise is, suppose I am using both this chat application in my mobile application and web app. How do we sync messages across? How we sync message across multiple devices? So consider the scenario, we use WhatsApp on our mobile phone most frequently. Suppose you use our WhatsApp application on our web app, as a web app, let's say a week ago, and after a week you are trying to run the application on the web server. So how do we sync those messages in your chat application in the web app, however it is already updated in the mobile application? That is the scenario which we will be looking into. So the question is, how do I sync reading messages across multiple devices such as my phone or the PC, etc. So consider a scenario, we will be understanding this with a scenario. So in our key value store, we have the ID, this is the sender, this is the receiver, and this is the text. So ID, let's say sender is A, B, C, 99, 100, 101, these are IDs. Receiver is, say, let's say Z in all the cases, and the text is A, B, C, D, E, F, X, Y, Z. Let's say this is an example. So a particular user, he is running on a mobile application, web application, and this is running on the mobile application. Both connect to the server. This is the chat server, and it has both user is a web session, I would say, and this is user is phone session. Both are running in the chat server. Each of these individual devices have a flag which maintains a flag, that is the called current max message ID. Both it is present in both this web server and also web application and also in the phone application. So what is this current max message ID? This is basically a unique message ID for individual devices, that is the web app and the phone, to which denotes the last message ID which has already been received or read from the key value store. So how do we know? So let's say this is 98, and let's say this is 99, or rather I will take it 100 to make the example more evident. And for the phone, this is, sorry, since our web app is not accessed frequently, so this is, let's say, 98, and for phone this is current max message ID, this is, let's say, 100. So for a particular device, how do we know a new message has arrived? So there are two conditions. We check the key value store. If the receiver is user A, let's say I make this A to understand the example, and this is Z, let's say. Yeah, if the receiver is user A in the receiver column of the key value store, and the message ID which we are looking into currently, or the row, should be greater than the current max message ID that particular device. So thus we know there is a new message. So here we update the application with the new message in each device and update the corresponding current message ID. So for web application we see 98, then we check that 99, 100, 101 are the new message IDs, and all of are meant for the user A only. So these are the new messages, and thus we update the web application with the new messages. Similarly for the phone we see there is a new message only, that is XYZ, which is remaining, and we update the phone application with the new message. In this way we sync message across multiple devices. So next we see how messaging happens in a small group chat. Small group chat. We'll understand this with the help of a flow diagram. So suppose again the user A sends a message to a particular group, so it connects with the chat server. What happens is, for small groups we have message sync queue, which we saw in the 1:1 chat application, message sync queue for each individual members. So let's say user B and user C are particular 3 members in a group. So the message is stored in the, along with the key value store, message is stored in the message sync queue of each of these users, user B and user C, and thereby what we saw in the 1:1 chat application, the flow diagram, how the message is sent to the user, it is being notified in the group and also the users. So this is easier. The pros of this method is, like, for a small group this is easier to implement, as each user checks its own inbox for a new message. Like user B checks his own message sync queue and user C checks his this and this, and this is for small groups. So storing copy of the message sent by user A in multiple message sync queues is not expensive. So this is from the sender's point of view. From the receiver's point of view, what we can say is, like, suppose user A has sent a message, user B has sent a message to the using the chat server 1 to the group simultaneously, and for user C it has its message sync queue. This is for user C. So the message for user A is stored in the message sync queue, and for user C also it is stored in the, for user B it is also stored in the message sync queue, and thus they connect. For a particular user, multiple people can send messages in this group. So this is the receiver's view. So this is how the message flow happens in a small group chat or in a 1:1 chat application, which we just saw. Third point, which is one of a requirement in the first video of this playlist, which we saw, that is the online presence indicator. So we will be discussing now how online presence indicator, like suppose you're in a particular chat application, you see a small green dot across the user profile photo in the chat application, denoting that the person is online or offline. So how this online indicator is being shown to the particular user, to his friend and all, etc., we will be discussing right that now. So online presence. So this is handled by the presence servers. These are another server in the system architecture. These handles the presence server. So their main functionality is responsible for managing online status, and the presence server, it communicates also through a WebSocket protocol, communicates with the client through WebSocket. This is evident because we need to persist the connection till the user is online or using that application, etc. So we will be looking this into 3 scenarios. Suppose case 1, the user logs in. So what happens when a user log in? So we have a WebSocket communication between the user and the real-time presence servers. So we have WebSocket communication between user and real-time service, that is the presence servers, and we store in the key value store, we store this pair, that is the online status and last active timestamp in the key value store for that particular user. So in this way, for a particular user who logs in, the online presence is being displayed. For a particular user who logs out, suppose user A is logging out, so it logs out, it sends the request to the API server to authenticate the logging out, and the API servers in turn after that communicate with the presence server to update the online or offline status, presence servers, and thus update the key value store. So what we update in key value store for user A, we have the status as offline. And the presence servers indicator shows that the user is offline. Another scenario is like user disconnection. So suppose there is a internet disruption between client and server, marking the user offline and changing status online. Once user reconnects, this is a naive way, and that too, for that presence indicator has to change the presence online presence status too often, thus making a bad user experience. So for this, what we use a solution is a heartbeat. So what is that heartbeat solution? So online client sends heartbeat to a presence server periodically, and if the presence server receives the heartbeat in the particular defined period of time, it is meant that the client is particularly online and the status of that client is shown online. If for a particular timestamp the last heartbeat which was received by the presence server was a certain period of time, and after that a threshold amount has been reached and there was no heartbeat from the client side, that indicates that the server that the sender or the user is offline. So client sends heartbeat to presence servers periodically. If say within X seconds heartbeat felt, presence servers indicate that the user is online, and if threshold reached from last heartbeat indicates user is offline. And the last status or the last step of this method is how do we notify the status change, that is online or offline, for users to users friends. Let's say user is friends, that is this is called termed as online status fan out. So we need to notify the user, notify in the sense we need to show in the UI of the user that the friend is currently offline or online. How do we do that? How do we fan out that notification? How do we fan out that service? So for that, what we use is a publish subscribe model. Publish subscribe model. So what happens is there's each pair of friend has a channel between them. So like suppose we are trying to fan out the status of user A to his friends, and let's say we have user B, user C, user D, and this is my present server. So there is a channel between user A and user B, user A and user C. So this for every friend pair there is a channel where the status of the user is published into this channels, and from this user B they subscribe to this channel and get the status. They act as the subscribers. Present servers, what they do is publish the status to each channel, and these channels are subscribed by users. Let's say we have user B, C and D, and the communication between the client and the server, as we have also mentioned, happens through WebSocket protocol. Communication between client and server happens through real-time WebSocket protocol. So the above design is effective for small user group. For instance, like WeChat, we use a similar approach because its user group is capped to 500. So for a particular group, among the users, among the friends, to see whether a particular user is online or offline, we can use this kind of thing. For larger groups, informing all the members about online status is expensive and very time consuming. So like suppose our group has 100,000 members, like 1 lakh members, and each status change will generate 1 lakh events, etc. To solve that performance bottleneck, a possible solution is to fetch online status only when a user enters a group or manually refreshes the friend list. So thus we have discussed about overview of how a chat application occurs, various components of a chat application, the network protocol, the communication between the chat application, how we store the messages, what database do we use for storing the messages, etc. So thank you for watching this video. Thank you for watching the entire series of designing a chat application. Stay tuned for more such interesting videos on system design, and I'll see you in a new video, new playlist.